very much for attending this session. I see we have an almost full room. That's great. So the topic for the next 45 to 60 minutes is modern lifecycle management using Visual Studio 2013 and Team Foundation Server. So my name is Michael Kьостер. I work for Microsoft Corporation. So my boss sits in America, and I'm part of the Visual Studio product team. But I myself, I'm based in Munich in Germany, and you maybe can hear that from my accent. People tell me I always sound like the bad guy in a World War II movie, so hopefully it's not too bad, but you'll have to make do with that for the next 60 minutes. So, modern lifecycle management. What is it all about? What do we mean from a Microsoft perspective when we talk about modern software development? And of course, I also want to show you quite some demos of some cool stuff that we have in our products, Team Foundation Server and Visual Studio. Who here is a Visual Studio user? All right. Who here uses Visual Studio 2013? That's not as much as I thought. So for the others, please upgrade immediately. Who's using Team Foundation Server? Any version? Okay, that's much less. So hopefully after today you will get a little bit of an idea what Team Foundation Server can do for you and for your team, and how a proper lifecycle management process powered by a lifecycle management toolset can really help streamline development, make it faster, and also help you overcome some issues that we see cropping up all over the place. So, topics for the next 60 minutes. First of all, I want to introduce or talk a little bit as an introduction, talk a little bit about some trends that we see emerging in software development. What is hot right now? What are some of the buzzwords that you will hear all over the place? And what do they actually mean? And then I want to dive a little bit deeper into managing the modern application lifecycle, basically the process of building a software application. It's not just about writing code and delivering code or a piece of functionality. In order to deliver a successful piece of software, there are many other things that teams need to focus on, that teams need to be aware of. And usually what we do from a Microsoft perspective is group a typical development project into 4 distinct phases. Starts with planning, then developers develop and test code. Then we release this application to production, and finally we monitor this application as it's used by real users in a production environment. So all of these phases need to be covered by a proper development process, and we have features and functionality in TFS and Visual Studio for each and every one of those phases. So let's get started. What are some current trends in software development? The first one is actually more a trend of how applications work today. When we look in a modern organization, in a modern enterprise, in a modern company that uses software, we tend to find 2 distinct flavors of business applications. We call them, on the one hand, systems of record, and on the other hand, systems of engagement. Now, systems of record are usually those applications. If those applications have a problem or if they go down, then the whole organization, the whole company has a problem. Those applications are absolutely mission critical, and if they break down, business just stops, and in worst case, a company could go out of business because they cannot do their primary business function. So those are mission-critical systems, and when we look, if we look at how these applications are developed and delivered, we see a very rigid way of software development here. So usually you have waterfall processes. So those are long-running projects, very complex projects, where everything is very well documented. It's not unusual if you develop and deploy an extension to a mission-critical application that your project will run 6 to 12 months, and there will be a lot of focus on quality, there will be a lot of focus on security, and there will be a lot of focus on making sure, before we actually put it out there, that everything works as expected. So that's one type of application. Those might be your SAP installations. Those might be your ERP systems, your manufacturing systems in your factories. So very, very important applications. That is why we need to be very careful if we do anything with those applications. But alongside these mission-critical systems of record, we see other types of business applications emerging. And those are quite different. We call them systems of engagement. And that is because those are usually customer-facing applications. If you look at the finance industry, an online banking application would be a typical system of engagement. End users are installing that, end users are using that. So what we have to do in order to deliver really great applications is to be very flexible when it comes to development. So usually what you see here is agile methodologies. So we put out a certain set of functionalities in the beginning, then we measure and learn how users are using our application, and in an iterative approach we add more and more functionality in small sprints, in small delivery cycles. Now, usually those systems of engagement also have a very big focus on the user experience. Usually they are branded. There's a certain branding that aligns with the company. Usually they're very easy to use because if you make them difficult to use, your users might drop off and you will lose customers. And they need to be very, very flexible when it comes to adding new functionality very, very quickly. So these two application types, they tend to coexist. So a system of engagement that deals, for example, with customer data still needs to connect to the back-end database, to the back-end system internally, but they have a very different focus, they work differently, and they're used by very different people. Now, we call, from a Microsoft perspective, it's a marketing term, if you will, we call this modern, these systems of engagement, we call them modern business applications. And a modern business application needs to be able to reach any device on any platform and any customer. So we cannot just lock people and force people to use a Windows PC, a Windows 8 app or anything like that, because usually our customers, they bring their own devices, their iPhones, their iPads, their Android devices, and they expect applications to work equally well in all of those platforms. So if we really want to deliver a successful modern application, we need to be able to cross boundaries, cross technology platforms. What we also see is that in many, many cases, these modern business applications require internet scale. I just have 250 users internally. I might have thousands, even millions of users worldwide running and using this application. And of course, if I want to provide a backend for this kind of scale, I need to be able to spin up resources almost at a moment's notice. If I see that more demand is coming along because we might have a marketing campaign that drives more people towards our application, I need to be able to provision the back end without a lot of delay. And that is why many of these modern business applications are at least partially powered by cloud backends. Because a cloud backend gives you exactly that. You can spin up, you can scale down, depending on demand, and it doesn't force you to invest in physical hardware, doesn't force you to put servers into your data center. You can just get more hardware, get more resources as needed. And when we look at the development process, we also see that more and more development teams use the cloud for actual software development. It's not just about hosting this application in the cloud, it's also about using the cloud for typical development tasks. One example that I'm going to show you a little bit later is load testing. Every application should ideally be load tested before we release it to production, just in order to figure out where's the threshold when our server infrastructure will go down. Load testing can help you do that, but nobody's really doing any load testing as of now because it's simply too difficult to ramp up a load testing infrastructure. And if you think about it, that's actually an ideal scenario for a cloud environment, because in a cloud environment, you can easily spin up this load testing infrastructure at a moment's notice. So again, this is just one scenario how development teams, developers use the cloud to facilitate their software development process. Now, another trend that we're seeing is that more and more organizations, not just development organizations, but companies realize how important and business critical software is. Now that's a quote from a IT authority, David Chappell. Maybe you have heard about him or saw him speak once. And what he says is very true. He says how well a company delivers, executes business strategies is ultimately tied to how good it is at developing and using custom software applications. And we see that happening all over the place because more and more businesses realize actually the software we're using needs to be tailor-made for our company. It needs to be customized for our processes. And actually the software that we're building to facilitate our business is a competitive advantage against our competitor in the marketplace. So the ability to develop, integrate and deliver custom software applications is strategic for all organizations out there. Somebody else said, every company is also a software company. And that's very, very true, because what we see is that those companies who get best out of a time of crisis are usually those who can tap into the magic of software. And that arguably makes developers and development teams the most important people in any organization, because developers are the people who deliver that custom application functionality. They are the ones that manage and keep up those applications. And again, without those applications, business would simply stop. So software is very important, and the people who manage software are equally as important. But if we look at the process, how software is developed, and put that against other strategic business processes, we can see that software development is very, very different. So for example, when we look at manufacturing processes are usually very, very detailed. They are standardization, ISO, and so on. Every step is written down. Everyone who is in that process knows exactly what is the next step, what do I need to do, and how do I need to document that. Or if you look at accounting, there's very strong rules about accounting for organizations, for businesses. And if we compare such processes to software development, we can see that it's very, very different, because in many places, software development is not documented. Software development doesn't have a process. No consistent process is applied, and that brings with it a lot of risks and a lot of uncertainty. If you don't have a process in place, then you cannot even answer simple questions like, how long will this project take? How much will it cost us? When will it be finished? These questions are notoriously hard to answer in any development project, and many times it's because nobody ever implemented an end-to-end process for building, delivering, and managing this kind of software. And that is what we're talking about when we talk about lifecycle management. Lifecycle management is simply the process of delivering and managing software in a predictable manner. Now, when we talk about the value of custom development, that sounds very good. And again, this quote is great. But if we talk to real people who have been in a software development project, they will tell us a little bit something different. They will tell us software development is difficult, takes a long time, costs a lot of money, and often goes wrong. Right? That's no IT authority that says these words. It's the voice of experience. And we've been all in projects that are troubled. We've been in projects that run over time. We've been in projects that run over budget. We've been in projects where at the end, when the project is finished, nobody actually knows why we started this project in the beginning, in the first time. Right? So software development is notoriously difficult. And the question again is, why is this so? Why do so many software development projects run into trouble or get outright cancelled? Because at first, it's actually very, very easy. When a company starts software development, building custom application, usually business users have a problem. They work with the development team, and the output is a custom application designed to solve this particular problem. That doesn't look so difficult, right? But over time, as you do more and more software development, you have more and more projects running, the picture looks something like this. Very, very confusing. You have many different people trying to work together, many different roles. You have different technologies. If you ever saw a .NET developer talk to a Java developer, you know what I mean. They're developers. They're supposed to be talking to each other, but they talk completely different language, right? That's an issue that we see in many, many projects nowadays. And it's not just the core process of writing code and delivering functionality. Alongside this, this core process, we have other processes for planning, or for release management. Actually, that's my favorite example. A release team nowadays should actually not be called a release team, because release people are operations people, and any change is bad for an operations guy. Never change a running system. It was an operations guy who came up with that. So if you as a developer come along and tell them, I have a great new functionality, can you release that? They're going to say, no way, right? I need to figure out that nothing happens to my production system. But these are some of the issues, this complexity, this difficulty to speak to each other, that can be solved with a proper lifecycle management process. And if you ever hear a Microsoft person like myself talk about software development, he or she will show you this graphic here, because that's how we see software development. It always follows the same phases. It always follows the same steps. It starts with an idea, right? We have an idea for an application. This application is supposed to do X for us. Once we have that idea, we make it a little bit more clear. We put down some requirements. We write down some user stories if we're doing Agile. And all these requirements make this initial idea much more graspable, and we understand what is needed to turn this idea into reality. Once we have a list of requirements, we hand it over to the development team. And that is when developers do their magic, because developers turn ideas into reality. That's the job description of a developer. It's actually a very cool job to be in. Once developers have built functionality and they delivered a working product, we're going to do some testing. We need to validate whether what the developers have produced is actually what our customers, our users, our stakeholders expect. Once this is done, we put this application into production. We perform more testing, we perform pre-production, validation, and then we install the application in the production system. We release the application to production. And once it's in production, the project doesn't just stop, because there is no application that gets released without bugs. There will always be bugs. It's impossible to not have any bugs in production. So we need to figure out what went wrong here, where's the problem, and we need to fix those bugs. And at the same time, we will get new requests for new functionality from our users. So the whole thing starts all over again. The whole cycle begins from the beginning. We add new functionality, we release new functionality, etc., etc. So a software project never really is over. It's only over if we take down the whole application and stop using it altogether. Then the development project is finished. But if you are in a team that thinks once we deliver code, the project is finished, that's actually not the right way to look at it, because there will always be work required in order to make this application better, in order to make this application more valuable for our end users. And this is how we see software development. Everything we offer with Team Foundation Server, Visual Studio, etc., all our tools, is supposed to help a development team run through that life cycle of an application and give you valuable functionality for each and every phase. What we're also increasingly seeing is that it's not just about delivering something, it's about building something, measuring how it's used and how people are using it, learning from these usage patterns, and then build additional functionality that makes this application even more useful. So it's an ongoing cycle of building, measuring, learning, and then building again. And that is also a trend that we see in software development. Things like continuous quality, continuous feedback, continuous delivery. Those are all things that fall under this build, measure, learn umbrella. And this is what nowadays is a big, big shift in the development industry. So this is our vision of modern software development. First of all, we need modern applications. The time when you could build a boring, rectangular, gray Windows desktop application with square buttons, that time is over, especially when it comes to user or customer-facing applications. We need a new class of modern applications that do not just work beautifully, but they look beautifully as well. So that is one thing, modern applications. And the frameworks you can find on the Microsoft stack, like Windows 8 apps, they have a very, very direct focus on what makes a modern app great. User experience, usability, ease of learning, and that kind of stuff. But it's not just enough to build these applications, you also need to manage them. And this is where our idea of modern lifecycle, following those 4 phases, comes in. And all is powered, should be powered, not just by a process that everybody understands, but also by a tool set that helps you run through your specific process. And this is what we're going to take a little look at now. So let's get started. If you look at each of those 4 phases, plan, develop, release, and monitor, there's a lot of features in Team Foundation Server and Visual Studio that can help you do that. The problem is we can never cram all those features into 45 minutes or 40 minutes now. Right? So I've selected some of those features that I think are pretty cool, but that's by no means an exhaustive list of everything that's in those products. So if you would like to see more, if you would like to play around with those features for yourself, the same virtual machine that I'm using for my demonstrations, that can be freely downloaded. And that virtual machine contains a complete installation of our complete ALM stack. So there's Team Foundation Server on it, there's Visual Studio on it, there's a lot of hands-on labs associated with that virtual machine, so you can look at each of those features, each of those phases, and try them out for yourself. I'll give you the link in the end, but it's a very, very popular download. So when we look at the planning phase, remember, planning phase is about making an idea for an application or a functionality more concrete. So what we do is we manage a backlog, we create requirements, we prioritize these requirements, and we make sure that everybody understands those requirements in the same way. And there can be many things that can go wrong all the way at the beginning, right? So what we invested in Team Foundation Server is to actually give you a complete management tool set that allows teams to run a typical agile project, do their sprint backlog management, do their feature management, do their planning and task management. All of that is now built into Team Foundation Server. So let me just quickly give you an overview of that. And usually I have to warn you, my virtual machine always implodes and shuts down and does nasty things to me. So hopefully it will not do that today, but we'll have to see. All right, so that's the virtual machine that you can download yourself. And on that virtual machine, there's sample data for a typical small agile project team. So there's an agile team with about 6 members, there's developers, there's a tester, there's a project manager, a release manager, etc. And all of these members fulfill different tasks, and all of these members have a different sort of speciality when it comes to skill set. Now, if you've ever used Team Foundation Server 2012, probably you've seen that before. This is a typical team portal that every team member can go to every day, and it gives you a pretty good insight what's going on in your project team. What we have here is this team of 5 people, and this team, for example, right now, has 33 items in their current sprint backlog. They have 1 bug, very, very good. Actually, you have multiple bugs, thousands of bugs even, and they can now start managing their daily work. But what's a bit special here is that this is not just one team working on this release. Actually, we have multiple agile teams working on different aspects of the application. So instead of having just one project portal for the database guys, for the web guys, and for the mobile application development guys, this team decided to separate those different work streams into individual portals. So for example, here we have the Fabric and Fiber web team, and they manage their own work. They have their own sprint organization. They do their own sprints, and even though their work aggregates back to a larger product release. Now, this has become very important in recent times. When we released TFS 2012, what we gave you was agile project management for one agile team, managing one centralized backlog, managing one centralized team project. But this is usually not how it works. So usually you have multiple teams working on one project, but as I said, having different kinds of specialization. So what we've introduced in 2013, TFS 2013, is what we call Enterprise Agile. You could also call it Scrum of Scrums. How do you aggregate multiple Scrum teams into one view? And this is what is enabled here, what allows you to do that here. When we look at this web team, you can see that they are currently in iteration 3 in their 3rd sprint, and it's almost finished. And here they can manage all the most important tasks for any agile team. So what is the actual most important task for any agile team? What do you think? Well, the most important thing in any agile project is a clean backlog. That's the thing that always needs to be really, really well prioritized. It needs to be up to shape. So that's also the first link on that portal, manage and view our backlog. Now this backlog looks not so impressive because there's two things in the backlog. But what you will notice here, the first thing is a bug that ends up in the backlog as well. And the second thing is a standard requirement. And we can, of course, add a new requirement. So let me just add one. It doesn't really matter what I put in here, but that would be a typical task for a product owner or for joint task for the team. And we can just add backlog items and fill up our little project portal with that. Now, one thing about Agile is that priorities can change at any point in time. And also, it's not a good idea to have a fixed requirements document or a fixed backlog for any Agile team, because they need to be able to reorder things on a moment's notice. So the nice thing about using this tool set is that you can drag and drop elements up and down, and you can reorder your backlog, because the high priority items should always be at the top. Now, of course, I should also add some more information. So if I double-click this thing, I can add more information to this requirement, things like test cases. I should actually do that right now, put in 1 or 2 test cases that validate the implementation of this requirement. I can do it later, of course, but it's a good idea to do it right at the beginning when you're doing prioritization and scoping for those requirements. I should put in some acceptance criteria. Very, very important. How do I know if this thing is finished? Only if I have a list of acceptance criteria can I really be sure. What I also can do, I can create storyboards. That's a feature that was also introduced with TFS 2012, because one of the #1 reasons why projects fail is because people don't understand what they're supposed to be building. Misunderstood requirements is the #1 reason why projects go wrong. Even a simple requirement that says user should be able to log in. Even such a simple example can go wrong in many different places. And I always take the Windows blue screen as an example of a misunderstood requirement. Somebody told the development team, we need an error message, an error screen in a catastrophic failure. And they thought, okay, let's build something that's useful for us. And the output was something that is useful for a developer and a technical person, but totally not understandable and scary for an end user. So storyboards can help you create requirement mock-ups. They can help you put something next to that requirement, to that textual requirement, that will help everybody understand better what was the original intent here. So you can do that here. Once we have our requirement, we start working on it. So we put it into our sprint backlog. And here you have a very lightweight effort management tool that allows you to scope the effort and see whether your team is overworked. What many people get wrong about Agile is that Agile is not about no planning at all. Agile is about the minimum planning absolutely necessary. So effort management still needs to be done. You still need to scope, you still need to plan, and this tool set is supposed to help you with that. What I would do now here is add individual tasks to break down this requirement, and those bars on the right-hand side would automatically update, show me what's going on. I'm not going to do that because otherwise we would be running out of time, but this is also a central task for any Agile team, manage their sprint. Of course, we also have a Scrum board, and we see more and more teams using that. They pull that up on the big screen when they do their daily stand-up meetings, and then everybody gets up and just moves their little virtual post-it notes around, and we can have a nice discussion about what's blocking me, what's going on, what I'm supposed to do today. And everything what you see here is actually powered by the live data that is in Team Foundation server. So TFS is the backend for this, but these management tools really were designed for Agile teams to facilitate their standard workflow, their standard way of working. Now, obviously, there's a little bit more to that. But what we're actually seeing is that such a web-based tool set, a very interactive tool set that allows you to easily reorder things, change things, etc. Okay, continue. Should give us a way of working easier. Now, one other feature that we've added recently is called work item charting. So usually when you have a project, you tend to have a lot of work items, whether it's requirements, whether it's tasks, whether it's anything else. So instead of having this flat list, work item charting allows you to take a query and chart it in any way you want. That is a nice feature for multiple reasons, because you can use it for reporting, you can use it for managing your own work, and it's very, very simple to do, very easy to use. UML modeling is something that we had in Visual Studio for quite some years now. Nobody's ever used it, not many people have used that, right? So I always emphasize the fact that if you have any kind of architect or head developer role, they should be creating some UML models, especially if your solution is very, very complex and has many moving parts. The only thing I want to mention here is that we have a full set of UML diagrams you can create, but you can also create work items in Team Foundation Server right from these diagrams. If you think about it, a use case diagram is an ideal source for requirements, because each use case maps directly to a requirement. So being able to create that directly in TFS out of the model is actually a very, very helpful feature. A sequence diagram like the one you see on the screen here can automatically be turned into a test case. You don't need to write a test case, you can generate it out of this diagram. So if you already have diagrams, it actually makes sense to use them as a basis for subsequent work. Other things that we have here is architecture tools. That is also something that is not exactly new, but this was designed to actually help understand existing code. Sometimes you're not starting a new project from scratch, you're inheriting a project, and you need to understand what is this thing, what does it do, what are the relationships, how does it work. That's not just for architects, that's also for developers. How often have you been thrown into a new project and you first had to understand what this actually is before you could create new functionality? It's a very common problem, and these tools can help you with that, because you can drill down into a complex solution, you can explore it, you can look at relationships, and you can understand how source code works. Now, this is what we call, using the architecture tools, is what we call the top-down approach. So you take a solution, you go all the way from the top, and you drill down into the last little details. The drawback and the problem with that is that when you start doing that, your simple diagram that you might create might explode into 1,000 different directions. Gets very, very complicated, very confusing very quickly. So in Visual Studio 2012, we introduced a new feature specifically for developers that facilitates the opposite approach, bottom up. And I'll show you that in just a minute. But the Architecture Explorer and the associated architecture tools can help you understand, diagram and document an existing system, and then later automatically create this documentation from scratch without actually having to do it yourself. So we have planned our little project. We created some requirements, we added some tasks, we did some UML modeling to diagram the architecture that we're envisioning. Now it's time to actually build that thing. So we hand it over to the development team, and developers start working, creating functionality. And of course, many things can go wrong in the development phase as well. So for example, you might have very diverse levels of expertise and knowledge in the development team. One developer might be new to the technology, new to the whole team. Another one might be a master, an old hand, and knows everything. So how do you make sure that every developer delivers the same level of quality, that every developer delivers working code? There are some tools that you can use for that, and I'm going to show you some examples of tools that we built into Visual Studio that help with developer productivity and collaboration. Now, going back to my virtual machine here, let me just put this to full screen mode. Now I'm logged in as one of the developers of this particular Agile project. I have my project open from source control, and I can now start working with this particular project. Now, one thing that we've added and that we've found, which is very challenging for many developers, is that they like to spend their time in the editor. And that's the right place to be as a developer. You're supposed to be writing code. But if you need some piece of information, especially information that is somewhere in Team Foundation server, you have to look around. You have to leave the editor, you have to run queries, you have to look at work items, and obviously that's a distraction, and this makes you less productive. So what we put into Visual Studio is this little gray line that you see over each method. This is called Code Lens. Now, Code Lens pulls together a lot of different pieces of information and puts it right into your editor window. So, for example, here we can see that this method, this class, has 2 references elsewhere in the source code. And if I need to go there, I can just click on those references in the little speech bubble here. I can also see, since it's connected to Team Foundation server, that there have been check-ins and who has authored this particular piece of code. So if I have a question, I can directly go to Julia and ask her what's going on here. I also can see change sets, recent changes. I can go back in the history and I can look at a previous version of this particular method. Again, this one is very dynamic. It updates dynamically, and I can even see more information. Like, for example, here we can see that this method has a test case, a unit test associated to it, and I can run this unit test right from here. I don't need to go manually to the test explorer and run a specific test. I can just say run all, and it will start working, and it will update this code lens indicator accordingly. Now, there's much more information that you can highlight, that you can display here. Test status, tested by, authors, changes, bugs, and there's even third-party extensions to Code Lens which give you even more information. Right? They give you helpful information about variables, for example. They give you help information, and all of that is context sensitive. It's available when you are working on your code. Now, that's an example of a productivity improvement, a productivity feature that is supposed to make a developer's life a little bit easier. Another thing what we put in here is, and I mentioned that before, when you get thrown into a new project, the first thing you usually need to do is to understand what's going on here. So what we do, we start reading source code. And we have a little pad of paper next to us where we make a drawing of all the relationships of the source code. Because the human mind is very bad at remembering short-term things. So as you jump through methods, as you jump through files, in order to find out what's making this application tick, once you've reached the 5th variable, for example, you've already forgotten the first one you looked at. Right? We're very bad at this as human beings. So usually we need to draw things, we need to write down things, etc. And this way of understanding by reading source code and jumping through different source code files is something that we also wanted to make a little bit easier. And this feature is called the code map. It's sort of a variant of the architecture tools I mentioned before, but while the architecture tools go from top to bottom, this one goes bottom up. So if I want to know what are the relationships, what's going on with let's see, which one can we take? Just go here. Let's say this customer object here. I can right-click any object. I can say show on code map, and it will now create a little drawing, a little map for me that I can step by step make richer. Now, one box is not very impressive, but as I'm moving through my source code, I can add new elements here, or I can explore those existing elements. So, for example, show me all the methods this particular object calls. It will now go through my source code, it will add these things, and it will update dynamically this little code map. And as I'm moving further and further into details, as I'm moving further and further through the relationships in my source code, this little handy map can help me get a better picture of the relationships of this particular piece of source code. And of course, you can go all the way up until you have every connection of your solution, but usually this is very useful if you just want to explore one method or a couple of methods or some piece of functionality, and then you can also share this map as with your colleagues, or you can check it into Team Foundation server so that you have this kind of reference for the future as well. What I also can do is I can flag things here. So let's flag this for follow-up. Let's add a comment here. So where do we have it? New comment. What's this? And in principle, this is the same thing we already do on a pad of paper, but this one actually is supposed to help you generate that on the fly. If I have more elements here, I can add them as well. Again, you can right-click any element, any variable, anything you want, and you can add that to your code map. It was actually the wrong link. Let's take this one here, show on code map. And again, this one will get bigger and bigger and help you a little bit figuring out what's going on. Now, there's another way how developers understand existing solutions, and that's simply starting a debugging run. Right? That's what we do. We do a debugger run, we set some breakpoints, we step through our code in order to figure out what's going on here. Now, in Visual Studio 2013 and 2012 Update 2, we actually integrated the code map feature with the debugger to create something called visual debugging. And what this does, as you step through your code, it will add all the elements that you're currently executing to the code map itself. So if I set a breakpoint here, let's just do that. If I do my debugging run, as soon as it hits the breakpoint, I can then click the code map button in Visual Studio, and it will add all these execution statements, all the variables, etc. It will dynamically update the code map for that. So let's just do a few step in, step in, step in. And when we go back to our little code map here, give it a little bit of time to update, it will add, actually I should first click the code map button to enable that. And you can see how these red things here not just only show you the presence of the cursor, but it also shows you where the breakpoints are located, etc. And as you work through figuring out what's going on here, it will update this code map automatically. And you can, of course, as elements are added here, you can still do show fields as references and all that kind of stuff. So again, this is supposed to help you understand what's going on in the debugging run. And as you can see, if you use both the code map from start and if you use the code map, the visual debugging feature, you should have a pretty good indication about the relationships in your solution very, very quickly. Again, that's a productivity feature that we built for developers to facilitate easier understanding of what's going on in existing piece of code, and it's actually a pretty cool feature. Other things that are not exactly new but are still part of Visual Studio 2012 and 2013. Now, just assume that I'm working on this particular feature and we all deal with daily interruptions, right? So I'm working here, I have my work item, I'm doing my debugging run. Suddenly my boss comes along and says, drop everything, you need to fix this other bug in this other project first. I guess everybody has had this situation, and usually what we do is we shut everything down, we save everything, we take away all the breakpoints, we close Visual Studio, connect to the other Team Foundation server, and then we start working on the other job we got. Now, since Visual Studio 2012, you have this feature of suspend and resume, which is supposed to help you with that. Let me just add a comment here. And suspend and resume basically gives you this suspend button here, which will not just save your current work, it will also save the complete state of Visual Studio. So any open windows, cursor position, anything like breakpoints, etc., will be saved to Team Foundation server. And then at any point in time later, once you've dealt with this interruption, you just click the resume link and everything is there where you left it off. So let's assume I'm finishing my work on the other project. If I want to go back here, I can just hit resume. like this, and everything will be restored. That is also just an example of a very small productivity feature that we have built in to facilitate developers, to make it a little bit easier to be a developer generally. So there's, of course, many more of these collaboration and productivity features. Wait, let me just show you one more, which is also very helpful when you're working as part of a team. So let's go back to the virtual machine. And that is actually a pretty new feature. Hasn't been in place for long, couple of weeks now. And that is called Team Room. Now, when you work with Team Foundation Server, and when you go to your project portal, there's a link to the Team Room, and the Team Room is sort of like a collaboration area, like a chat room for my development team. It's also a historical record of what's going on in my project. So I can go there, I can invite people for chatting, I can add things like @Brian, and I can say hello to him, whatever. But that's not really very impressive, right? I can also put in just created work item number 245. Later, Brian can just click that link, will take him directly to that particular work item in TFS. But what you also can do is you can add events to this team room. So whenever a build completes, a notice will appear in the team room. Whenever any code changes, it will be posted in the team room as well. Whenever a work item is updated or changed, that will appear in the team room as well, right? And if you think about it, since this gets never deleted, you have a historical record of whatever's going on in your project on a given day. So if I'm on vacation for a week, I can come back later, and I want to know what has happened in the last 7 days. I can just go back in time, and I can see whatever happened during that day. Nothing, here happened some more things, and I can look at all these events, and I can get up to speed very quickly. Many teams are also using the team room for capturing their notes in their daily stand-up meeting. Again, since it's a historical record, it will never be deleted. You can also use that as a holding area to record anything you want in the team room. So that's a new feature. And again, this is available in Team Foundation Server, and it's available out of the box. Another feature that I think is very important and which is very undervalued are the code quality tools that we have in Visual Studio. We had those code quality tools for quite some time, and especially if you have a development team where each developer has a different level of expertise or knowledge, the code quality tools can help you make sure that everybody creates the same level of quality when it comes to code. So actually all of you are already very familiar with the most popular code quality tool. It's called static code analysis. Now static code analysis is what happens when you hit F5 to compile. You get errors and warnings. That's the code analysis engine going through each line of your source code and flagging any issues. What many people don't know is that this engine is much more powerful than just flagging compiler errors. You can actually extend it yourself. So in Visual Studio, there's a lot of rules already built in, and you can add your own rules since Visual Studio 2012 to facilitate validation of your own process, of your own rules in your development process. Any developer at any point in time can start a code analysis run. So let's just do that here. And usually what tends to happen is you get a very long list of things that pop up. And that is because all these rules, they follow best practices and they flag any violations that you might have in your source code. You don't need to deal with all of them because that would take a lot of time, but some of them can, if you address them now, it can help you fix issues before they actually become bugs. So for example, in our example here, I know that there's a certain thing that gets flagged all the time. That is my developer Julia is using a lot of locals here, local variables, and that's usually not a good practice, especially if you don't use them. right? So the code analysis engine will flag that. It will show me the location in source code. It will give me a little bit of a help text on the right-hand side, and I can either fix that now, or I could also create a bug in Team Foundation Server so that somebody can look at that a little bit later, right? The code analysis engine is in every version of Visual Studio. So actually every one of you who's using Visual Studio should use it on a daily basis. And it really can help drive up quality of code. And that is one of the code quality tools that we have in Visual Studio and Team Foundation Server. There's a couple of other code quality tools. Generally, you will find them in the Analyze drop-down, Performance Analysis, which looks for issues in your code that could impact performance, code clone analysis, which is very helpful for refactoring purposes because it finds similar pieces of source code in your solution, and a few others as well. So take a look at those, because in your daily business as a developer, they can make your life quite easy, and they are quite easy to use as well, since most of them are wizard driven. There's nothing special needed for that, so definitely take a look at that and see if it's helpful for you. Now, in our process, we built some functionality, we developed some features using collaborative tools to help us with that. Now it's time to actually test those features. And there's different level and different types of testing you can perform. What we've been trying for a couple of years now is to make TFS and Visual Studio one of the best testing tool sets that's out there, at least for .NET developers. So what we've done is we added a complete manual testing solution in the form of Microsoft Test Manager. And the Test Manager can help you manage your testing effort, your manual testing effort. It can help you run test cases that you create. It can help you collect a lot of information. That is actually probably the most important feature in the Test Manager, that it automatically hooks into the tester system, into the user system, and collects a lot of information automatically. So usually when you have a manual tester, they are never giving you as a developer enough information to be actually able to diagnose and fix a bug. Right? They write doesn't work or crashes. That's not very helpful, right? I need more information. And the diagnostic data adapters in our testing solution, they will give you that information. They collect simple things like what browser is the tester using? What operating system version is he using? That's very helpful to replicate this error. But there's even more complex information, like a complete snapshot of what's going on in my application. So if I capture this snapshot, I can import that later into Visual Studio and step through my code as if I were doing a local debugging run. So this is called IntelliTrace, and IntelliTrace enables me as a developer to do historical debugging. I get all the information that I need to be able to actually fix this particular issue, fix this particular bug. Another thing that is facilitated by the Test Manager is that when I run through a test case, everything I do on the screen will be recorded. And this recording can be playbacked a little bit later. So instead of running through my test case again in order to do regression testing, in order to validate that a certain bug has not reappeared, I can do that automatically, like in a video recorder. Just select the steps, hit play, and everything will be played back magically from the start. Actually, I have another session on testing tomorrow where I will show that in much more detail, but just for you to know, an integral part of an end-to-end lifecycle management solution and process is, of course, testing. It's incredibly important. So we also have those tools available to facilitate proper testing, both the manual kind and the automatic kind. One other step, which I'm going to show tomorrow as well, it's very nice to have manual testing, but manual testing is very time intensive, takes a lot of effort, especially if you want to do more manual testing. So the next step in sophistication would be to automate the manual testing effort. We call this coded UI tests, which allows you to turn a manual test into a fully automated test in the form of code. So with one mouse click, you get code that expresses the different actions that your manual tester has done in this particular test case. Once you have it in code, you can do very sophisticated automation. You can connect to a database, for example, and pull a list of users and passwords to dynamically create login scenarios for an example application. You can do other things as well. You can compare things to each other to make sure that all is working as expected. Since this is code, it can be part of a automated deployment, and it will run without any human intervention. Again, test automation is the next level in sophistication when it comes to testing. And again, in the testing session tomorrow, I'm going to show an example, a simple example, but you can go to very, very great lengths of complexity. Finally, in the testing area, one trend that we're seeing happening right now is that development teams are no longer testing on physical environments. That is, they don't have a test machine under their desk where users are doing acceptance testing. They're moving that to virtualized test environments in the cloud. Again, if you think about it, in the cloud, you can have as many virtual machines as you want in any combination, in any level of complexity. So what we have in Visual Studio and TFS as well is a way to manage these test environments in a nice user-friendly way. We call it the Lab Manager, and the Lab Manager can be used to organize virtual machines, pull them up, install the environment, run the environment, and if you're doing this test run on such a virtual environment, you can even take a complete snapshot of the whole state of the system in this particular second when the bug appears. That is also a very advanced topic, but we're seeing a lot of interest here because, again, setting up physical test environments is usually very time intensive, costs a lot of effort, and since you need powerful hardware for that, it's also very, very expensive. So again, this is also something that I'm going to talk a little bit more about tomorrow. Now, once we've tested our application and we are reasonably confident that everything is looking and working as it's supposed to look and work, it's now time to put that into production. We're going to release this application. Now, releasing an application to production is usually a high-stress undertaking. Right? Because first of all, you have not just the development team involved, you also have the operations team involved. And the operations team is usually the ones that get blamed if things do not work right at the end. So they're they really want to make sure that nothing bad will happen. And this is why releases very often take a long time. But even before we release to production, we usually have to go through multiple pre-production environments. There's QA, there's integration, the integration testing environment. There's the user acceptance testing environment. How can we make sure that our application is always installed in the same way, that it always follows the same procedures? And how do we make sure that this process is always followed in the right, in the proper manner as defined beforehand? And this is what we do with release management. Release management happens after you have a compiled build of your application, and the release management tool will pick up this build and deploy it subsequently through all the different instances and waits for feedback, waits for approval if this is necessary. Now, release management is something that is brand new. We have just now started to put release management, fully automated release management functionality into Team Foundation Server. But basically, this is a tool set that allows you to automate the deployment and installation of your application, so there's no manual intervention required. Usually what we have is a different set of tools. We might do it with PowerShell, we might do it with homegrown tools, we might do it with some tools from third parties, but release management is supposed to take all those tools and do a fully automated deployment, picking up the build and then moving it through all the stages. So you can do release automation, by laying out the release process in a visual way. You can see it here. That's a deployment sequence. You add steps to the deployment sequence. You configure those steps. And then the release management tool will follow those steps whenever a new build arrives in the drop location. If you have manual approvals, so somebody needs to verify whether everything's working as expected, you can ask them for approval, and they can add the approval in the interface of the release management tool. It's all integrated with Team Foundation Server, so as you can see here, as soon as the build has been copied to the drop location, release management is started and the build will be picked up and deployed as outlined in the deployment process. And of course, you at any point in time can look into what's going on. Here we can see we have 3 releases, and we can see that these releases usually go through development, QA, and then to production. And we can see double click and drill into any kind of issues that might happen during the release process. I'm going to show a little bit more tomorrow again as well. But release management is definitely one of the big blockers for many development teams out there. Because you, as a development team, can be as agile as you want. If your release takes you 6 months, then it doesn't help you. Your customers and users will still be unhappy about the process. And finally, the last phase in our step, in our process, is to monitor. We need to monitor the running application as people are using it, but we also need to monitor our project, right? I said before that if you have a process in place, it becomes actually very easy to have at any point in time an insight into what's going on in the project. So what Team Foundation Server brings with it out of the box are reports like these. Actually, that's my favorite report, because you only need to look at this report to know if your project is in trouble. So what we have here is a list of all the requirements. We have a completion level of those requirements, and we have the test results for those requirements as well. So what we can see here is that the number one, the one at the top, the requirement, has been completed, but not all tests have successfully passed. So we still have to do some work in order to have a high quality requirement at the end. A little bit lower, we can see that some features are not completed yet, some user stories are not implemented yet, and we have some open bugs here. So by just taking these 3 pieces of information, requirement, how far along are we in completion, test cases and test results, we can create a report that we can send around to our stakeholders, and we don't need to go to each individual team member and ask them, hey, what are you doing? How long will it take, etc. I have a complete insight here. That's actually the number one benefit of having a system like TFS, a central bucket in the background that will collect all that information and then allow us to create these automated reports out of the box. Now, the last thing before I finish is there is Team Foundation Server, the server product. That is the one you download, you install, you manage yourself. But most recently, we have introduced something else called Visual Studio Online. Basically, Visual Studio Online is an exact copy of Team Foundation Server, which is hosted in the cloud. So you can go to Visual Studio Online, you can sign up with a Live ID, and you will get almost the full set of functionalities of Team Foundation Server for free. So if you want to play around with project management, you want to use the project management tools I showed you, if you want to do testing, if you want to do analytics, if you want to see what's going on, Visual Studio Online gives you all that functionality. And if you go to visualstudioonline.com, you can simply sign in and sign up, and in 5 minutes you will have your own team project portal up and running. Of course, it also contains source control, etc. So this tool set allows you to plan, build, deploy, and manage application development without installing your own Team Foundation Server. It's very easy to use, so just go there. If you haven't done it yet, go there, sign up for it, and that's the best way how you can start using that. Now, obviously, we have features for planning, developing, operating, but there are also some features which you only get in Visual Studio Online. And those are scenarios that lend itself ideally to a cloud infrastructure. So, for example, I mentioned already load testing. Load testing is a very interesting scenario because in order to do successful load testing, you will need a very sophisticated hardware infrastructure for that. You will need physical computers to create that virtual load. And this can be very complicated, very expensive. So doing that in the cloud with a few mouse clicks is actually something that will make load testing much, much more interesting. So in Visual Studio Online, when you sign up for that, you get the ability to do cloud load testing. Another scenario where cloud infrastructures become important is build. When you see that your builds are running too long, you can add more physical hardware, scale out your build infrastructure, or you can move the whole build process to the cloud. Because in the cloud, you will always have more than enough hardware resources. And if you want to drive down your build time, if you want to make your builds faster, using the cloud for building and number crunching is actually a very worthwhile scenario. So that is also something that you get with Visual Studio Online. And using Cloud Build is as easy as switching to the hosted build controller. It's one mouse click, and then your application will be compiled in the cloud instead of on your own hardware. If you're looking at continuous integration, continuous deployment, build time becomes very, very important. Because obviously in a continuous integration scenario, waiting minutes or even hours for a build to complete is a no-go. So that is where we see cloud building in the cloud becoming much more important. And the last cloud service that you get with Visual Studio Online is called Application Insights. Application Insights is app instrumentation. So you add some code to your application, to your web app, to your Windows 8 app, and this code will send usage data to a service in the cloud, the Application Insights service. That service will collect all that data, do some number crunching, and give you reports of how are people using my app. What's the typical path they take through my app? What are the most used features? Where do they click? What button do they click on? And are there any performance issues that they might have? You would never get this information, but with instrumentation, you can get a very rich insight into how people are using your application. Now, for example, the Visual Studio team knows extremely well what button you guys click on in Visual Studio. We know each and every toolbar button, and we can measure how many people are clicking on that button, what are they doing, which button is most popular, and that's how we can make decisions for future releases to take things away or move things to make them more prominent. That's application instrumentation, and the Application Insights service gives you a very easy to use turnkey solution for that. So those three services are part of Visual Studio Online, and even if you don't want to use the project management features, load testing, building, and Application Insights is very, very worthwhile. With that, I'm at the end of my session. I'm a little bit over time. I apologize for that. If you want to use Visual Studio Online, it's free for up to 5 users. Just go ahead, sign up. You will never pay for it. And if you have MSDN, anything you want to do with Visual Studio Online is covered as well. It's all included. That also goes for the cloud services. So if you use the free version, you get 60 minutes of build time per month. And if you go over that time, you have to pay, at this point in time, it's 5 cents per additional minute. Same goes for load testing. You get 15,000 virtual user minutes. That is usually number of users simulated times runtime of the load test gives you the virtual user minutes. So if I want to simulate 1,000 users for 10 minutes, I have 10,000 virtual users, right? So if you go over the 15,000, you have to pay for that as well. And the Application Insights service is so new that we're still working on that. And for now, it's completely free. Summary, again, successful software development requires you to take a step back and look at an application's life in an end-to-end fashion. It's It's not enough to just write code and deliver it. Those times are over. You need to manage the life cycle of an application from the first hazy idea all the way to the end when it's running in production. And it will never stop. It will only stop if nobody's using the application anymore. That's just the new world of software development. Team Foundation Server, Visual Studio are supposed to help you with that. I could show you only a handful of things we built into those products for each phase, but there's much, much more to discover, much, much more detail. And for that, I'm going to fire up the download page for the virtual machine. So you can download the same virtual machine with everything installed, just play around with it. With that, thank you very much for staying all the way to the end.